Welcome to Radiant Sky Solar Channel. So in today's video we are going to be talking about solar charge controller. Okay, so let's understand how solar charge controller works. What is the role of solar charge controller in the solar system, how it works, and the different types of solar charge controller out there. So my name is still Engineer Chooks. I'm super excited to have you here. So if you are new to this channel, make sure you are subscribing, or you are liking and you are sharing this video with your friends on social media. So welcome to today's video. So I want us to look at solar charge controller because this is an important aspect of a solar system. So solar charge controller is one of the major components that enables solar system. So let's want us to look at solar charge controller so that you know how to make decisions on charge controller when designing a solar system for yourself, for your clients, or for use in any situations. Okay, so let's go into the main topic. So what is charge controller? So solar charge controller, simply put, you can call it also a solar regulator. Okay, so it's just a device that regulates the voltage and current that comes from the solar panels to the batteries, ensuring that the batteries are charged safely, efficiently, while preventing overcharging or deep discharging. So that is the work of solar charge controller. It regulates the voltage and current from the solar system, from the sun, from the panel to the batteries. That is the work of solar charge controllers. Okay, so the main power here, as we have all said, as we have seen in this definition, the main work of solar charge controller is to regulate power from solar panels to the battery bank. It also prevents overcharging, which damages battery or shorten the lifespan of battery. So when you connect your solar your panel directly, if you have a right connection and all that, you connect the wire of your solar panel directly to your battery, it can charge your battery, but then it's not healthy. Okay, because there is nothing regulating the current that is coming, there is nothing regulating the voltage. Peradventure, there is intensity of sun, and the sun sending high voltage is going to go straight to your battery, no regulation. So all those kind of situations can warrant whereby your battery cells can be affected, or they can be damaged. Okay, but if there is a charge controller there, whether there is a high voltage or high current, the charge controller will manage it, will resolve it, and give out the appropriate current needed to charge the battery. So you see the role of solar charge controller now. So it prevents over discharging. Okay, so if there is a load, if you connect a load to your battery, okay, through the charge controller, once the battery has gotten to an extent, to a certain voltage or low voltage, it's going to cut off. Instead of draining the battery to the aspect of discharging all the battery current, which in some types of battery like lithium battery or dry cell battery, they are not recommended. If you drain the battery that way, you can kill the cells. So the charge controller will manage all these aspects of current flowing to batteries and all that. So that is the work of charge control. As you can see, it's very important in the solar system. A device that can prevent your battery from damaging and also helps your battery to charge very efficiently, I think is actually very important. Okay, you can also find charge controllers, not all, but some charge controllers that also can monitor some load fixtures or battery percentage of your battery. So you can, with there, you can know the state of your battery, or know how full or how the level of your battery and all that. Just like, more like a screen on the charge controller, or a fixture in the charge controller that can analyze the battery and give you a feedback of the state of the battery. So some charge controller also have those fixtures. So basically that is what you need to know about charge controller. With all this said, let's look at, really understand how charge controller works. We already know that it's a device that, okay, manage current and all that, but let's look more into details, understand really how charge controllers work. Okay, so first of all, one of the things that charge controller does is voltage regulation. We talked about it. Okay, so the controller regulates and step down the voltage to the correct level. Okay, so for example, now if you are working with a charge controller, you might do your connection. Let's say you want to power a 48-volt system. So if I'm using any terminology that you're not clear about, don't worry. As we progress, we are going to explain everything about voltage, about all this. But take this for instance. If you are using a system of 48-volt system and you have a panel that you are connected up to 100 volts, you run a panel connection that is giving you 100 volts. Okay, So if you put that into a battery terminal directly, okay, imagine putting a 100 volts volt on a 48 volt battery, okay, or which has about 60 maximum charging current. If you put that solar panel there, that voltage looks very high for that battery, okay. If it's not regulated while charging and all that, it can damage the cells of battery. So that is where solar charge controller come in. So you have a battery of 48 volts and you did your connection and you're having about 100 volts. When you slot it into charge controller, it will regulate the volt. It's not going to take away the voltage. It's going to manage the voltage, but giving out the right voltage that the battery needs to charge very well. Very, very important. So that is what one of the works of solar charge controller, regulating voltage, okay, that it gets to give out the appropriate voltage that will be suitable to charge the system. So another thing it does is current regulation. So there are two major aspects of power that solar panel generates. Solar panel generates voltage, it also generates current. So voltage and current are the two major electrical energy that solar panels use to charge this battery. So charge controller also does the work of managing current, okay. So it limits the current of flowing into the battery to avoid overheating or overcharging. This prolongs the lifespan of batteries also. Same thing with voltage. So when you are generating excess current, okay, instead of hitting all the current on the battery, the charge controller will step it down, regulate it, and provide the normal size or capacity that is required to charge the battery very well. That is another work. That is how charge controller works. So another thing that charge controller does is that it charges battery in phases. So one thing you need to understand is that batteries charges in different phases. If you really want to charge your battery to be very, very solid, okay, to be well charged, it has to charge in different phases, okay. And with charge controller, all those things are well managed, okay. So when it comes to charging of battery, there's what we call bulk charging. So when you run your battery down now, let's say you are using your battery and it runs down and you try to charge it, let's say the sun comes out and wants to charge that battery, there is going to be a phase whereby the energy, the solar charge controller is going to push in high energy and power on, okay, to charge that battery. Because it's low, it's going to boost it to charge up, to boost it up. So once it has done that phase, it can do that to charge up to 50 or 60%. After that, it now starts absorbing charge. Absorb charging is where it will now solidify the strength of the previous charging. The bulk charging is just more like boosting the battery. Then on the absorption charging is whereby it solidifies the strength of the charging, okay. Then flow charging is whereby it now kind of seal up everything. By then your battery might have been full, but it now goes gradually small to finalize the whole essence of charging. So all these things are the stages that goes on when a system is charging a battery, either inverter or charge controller and all that. So all these characteristics are built into charge controller. They manage all these things, all these stages of charges. So charge controller knows when a battery is totally low, the battery is very low. It knows when to give it enough power, enough voltage, enough current to boost it. So charge controller also can sense when a battery is getting to be filled up. It knows when to change the direction of the charging or the approach of the charging to absorb charging, to solidify the energy that it has charged in the bulk charging. Then you also know when the battery is getting filled up, where it now flows and charge gently to solidify everything. So these are the different stages in charging, and charge controllers follow all these. So these are the stages they follow through to charge batteries, also that extend and improve the lifespan of batteries, okay. So just understand that batteries or solar system with charge controller or even inverters, they charge in different stages, okay. So also temperature, because charge controller also controls high temperatures and all that. Some of them have sensors, okay. If the temperature is more, it can give an error code, or it can trip off, stop charging to allow everything to cool down, then it can start again to charge. All these things are things that will allow you to charge your battery efficiently and also extend or prolong the lifespan of your battery. Now imagine without all these devices, you can send high current to your battery, you can send high voltage to your battery, you can send high temperature to your battery. Your battery will not charge very well in different stages to help it charge well. All these things will make, okay, charging inefficient, okay. But charge controllers handles all these things, okay. So with this noted, this is a diagram view of what a charge controller in action. So this is a type of charge controller. Okay, so it's very simple. Depending, you can connect 10, 5, depending on the numbers of panels or your configurations or your design, whatever means. This is a diagram of solar charge controller. The batteries are always connected to the battery terminal on the charge controller. Then the PV are connected to the PV terminal on the charge controller. So there can be other connections. The panel can go into protective kits like PV surge breakers and all that before coming here. Likewise the battery. Okay, so one thing we get to understand is that most charge controller have DC outputs. Okay, DC output is the current, DC current that battery produce, solar panel produce. You can also give an output of DC. If you have DC or electric bulbs, if you have DC charging devices and all that, you can power them with your charge controller straight up from your charge controller. Okay, now you cannot power AC here because this one don't have the ability to convert DC current. This charge controller don't have the ability to convert AC current to DC current to AC current. It's only inverters that does that. So they don't have the inverter ability. But basically that is what you should know, and this is what you should know about charge controller and how it's all connected. Don't worry about it. This is a preview. So we are going to do more details. We'll explain more about charge controller capacities and all that. We'll talk about designs. Then before we can talk about how you can connect them in a live case scenarios. Okay, but with all these things highlighted, let's look at, there are different types of solar charge controller, two major types. So we have PWM, pulse width modulation, that is what is known, and MPPT, maximum power point tracking solar charge controller. So these are the two major types of solar charge controller. So let me highlight them so that you get to understand. So PWM, pulse width modulation. So this is an older type of charge controller. This is more like older technology when it comes to charge control. It's not that complex. It has the ability to charge batteries to an extent. Okay, though not efficient like other type of charge controller, but is this is more like the older technology. PWM also has the ability to match panel voltage to the battery voltage. Okay, so it has the ability to manage panel voltage to suit the battery you are charging. Okay, so remember all these charge controller always have specifications. You don't just go there and buy any type of charge controller. There are always specifications on charge controller. They are the ones that are rated 12 volts, 24 volts and 48 volts. They are the ones that are rated 60 amps and all that. Some of them will have a maximum voltage output. So all these things are always put into consideration when choosing any type of charge controller you want to work with. But one thing you should understand about PWM is that they can match the panel voltage to the battery voltage. Okay, so for example, if you are running a PWM, if you are using a PWM to charge your panel, you need to always be concerned about the voltage. Okay, so when you are running your connection, let's say you have 48 volt system, you must make sure that your connection, your PV connection, your panel connections align with the voltage of the battery system you want to charge. Okay, so even though you have something a little bit higher, okay, than the voltage you are charging, so PWM can manage that. It can provide the right voltage that will help you charge the battery. Okay, but this PWM don't always accommodate much voltage. That is actually one of the limitations. So it's also less expensive and less efficient, I mean, when it comes to voltage. So for example, like I said, if you are putting a high voltage panel on PWM, it doesn't have much effect. Okay, because it doesn't have that ability to convert voltage into current and all that can be done in other type of technology, but it's less efficient. So if you are doing a connection on PWM, you always have to work with the range of voltage you are charging. If you are charging a 48 volt system, your connection should be within the 48 volt, okay, system. Also, it should not be less than, it should be higher than 48, even up to 70 or 80. So but when it comes to voltage, you can't put in more voltage in PWM and expect to get higher efficient power supply from them. That is just how it's built. Okay, so it's also best for small system. Okay, if you are charging lithium battery and other type of sophisticated battery, it's recommended you make use of the other type of charge controller. Okay, so it's good for small system. So with this said, let's look at MPPT, maximum power point tracking system. So this is a more advanced type of solar charge controller. So this one is more efficient and is also more advanced, more about latest technology of charge controller. So MPPT use what is called maximum power point to track solar panel. Okay, so this helps them to be able to perform efficiently. Now what this means is that if you have an excess voltage, okay, connected of panel to your solar charge controller, an MPPT solar charge controller, let's say you are charging a 48-volt system, okay, then you have a connection that is running on almost 120 volts of solar power. Okay, what MPPT charge controller is going to do is that those excess voltage, okay, those excess voltage that is present in your system, it can convert it to current, okay, which is an element of energy that can be used to charge your battery. So you can convert that to current and be able to also work efficiently without losing power. You're not going to lose, okay, all those excess voltage your panel is providing, because the charge controller is going to convert it to current, convert it to the right current that is needed to charge battery. That is one of the amazing work that MPPT charge controller does that make them outstanding. Okay, the ability to convert excess current and excess voltage to charge batteries. Okay, that is why I said it can convert excess voltage into additional current to help you charge your battery. So this also is more expensive. Okay, so MPPT solar charge controller is more expensive. It's more expensive compared to PWM, and it's also ideal for mismatch voltage. Okay, now what is mean by mismatch voltage? So wherever you have, let's say you want to charge a 12-volt system, your battery system is 12 volts and your solar panel is 24 volt, 34 volt and all that. So with MPPT you will not have an issue. Okay, you will not have an issue charging that system, because MPPT can convert the 24 volt panel that is being connected, it can convert it to provide the right voltage. Okay, it can convert it to provide the right voltage that is going to be suitable to charge a 12 volt battery system. So it has that ability to manage mismatch voltage system where you are using different voltage of battery and different voltage of panels. MPPT can handle all those tasks. Okay, so you see why it's more advanced and very, very expensive, more expensive than PWM. So basically that is it about MPPT solar charge controller. So these are the two major types of solar charge controller you will be working with as an installer, as an engineer. These are the charge controller you come across. So the one you are going to be using is going to be dependent on the kind of system you are building. It's also going to be dependent on your budget. Okay, so basically that is it. So with all these things said, there are some features you can see in modern charge controller. So apart from being an MPPT, there are other features that can be built into charge controllers. Now you don't expect these features in all charge controllers. All these features are based on the manufacturer intention or what they want to build into their own system that will determine the features your charge controller will come. So a charge controller, even MPPT or PWM, they can just come as plain as they can just come as plain as it is, just a way for you to do your connection and a simple screen reading to know the level of the charging and all that. They will not come with any other extra feature, but you can also come across charge controllers that will come with other features, so which include like LED lights and LED display where you can read and monitor the progress of the charging. Okay, they can come with USB port. Some of them come with USB port that you can use to connect every kind of USB device or charge phones and all that. You also see them in some charge controller. Some will come with Bluetooth or Wi-Fi monitoring, which you can use to connect to an app or to your phone to monitor the state on how your system is charging. So some of these MPPT charge controller come with these features. Okay, so we also have load control, turning off on automatically. So there is, if you want to use the DC, let's say you are connecting your solar panel to charge controller and you want to power DC devices from your charge controller, there is a place where you can connect the DC devices, wires and all that. So some charge controller also can have a way for you to turn on and off that feature, the DC output of your charge controller. So these are the features you might come across. So some charge controller also can be very intelligent and smart enough to detect errors. So once they detect errors, they can give you an error code which can help you to troubleshoot the system and know what is the issue. Okay, while some have a mechanism or feature that can automatically help them to shut down when they experience on error or any spark or surge that can be harmful or that can destroy or damage the system. So these are just features manufacturers built into these devices, okay, to make them more advanced and effective. So with this said, these are some of the features you can find in modern day charge controller. Okay, that is all I want to share with you about solar charge controller. Okay, just to help you understand these components. These are very important components. It's good that you understand all these things. So when we start to talk about system design, we are going to be mentioning them. We are not going to be we will not try to explain what they are or how they work on different types of again. So when we talk about them, you already know what we are talking about here. Okay, so basically that is it for this video. I'm so excited, and thank you for watching to this extent. Okay, so before you go, make sure you are subscribing to the channel. Give us a thumbs up on this video if you really enjoyed and learned one or two things from it. If you also have questions regards to this training a whole or this video, use the comment section below to ask your questions. I will be glad to be attending to them. Okay, so thank you very much for watching, and I will see you in the next one. Bye.